In this lecture video, we'll be understanding Routh-Hurwitz criterion, special case 2. The topic which is covered in this lecture video is numerical based on Routh-Hurwitz criterion, special case 2. If all the elements of a row in a Routh array is equal to 0, then that condition or that case is called as special case 2. For example, let me consider the coefficients as shown, the Routh array as shown. A, B, C, D, E, F forms the first two rows of the Routh array, and the third row of Routh array I have considered as 0. All the elements in the third row are 0. So when all the elements of a row in a Routh array is equal to 0, that gives us special case 2. There are certain steps which has to be followed in order to overcome this difficulty or to eliminate this difficulty. We have to form an equation by using the coefficients of a row which is just above the row of zeros. Such equation is called as auxiliary equation, which is denoted by the symbol A of S. In this particular example which we have considered, we have got all zeros in third row, h to the power of 3 row. Just above this row, we have certain coefficients. We have coefficient D, we have coefficient E, and we have coefficient F. Some values we have. So by using these coefficients, we will be forming equation, and that equation is termed as auxiliary equation. So this auxiliary equation has to be formed by following certain steps. The coefficients of the row are corresponding to alternate powers of S, starting from the power indicated against it. Hence, D is coefficient corresponding to s to the power of 4. So the first term is ds to the power of 4 of auxiliary equation. So if we observe this example which we have considered, we can form the auxiliary equation as follows. The first term in our auxiliary equation A of S will be equal to the coefficient which we have at the start is D. So that will be the first term. And against this D we have S which has the power of 4. So the first term will be ds to the power of 4. Next, the coefficient E is corresponding to alternate power of S. That is, from s to the power of 4, it becomes s to the power of 2. Means we'll be taking alternate powers of S. Hence, the term becomes E s to the power of 2 and it continues. So, the auxiliary equation will be equal to A of S equal to the first coefficient which we have is D. Against this D, the S term which we have is s to the power of 4 plus the next coefficient which we have is E s to the power of, we have to consider alternate powers of S. So after 4, we should not consider 3, we have to consider 2, alternate power of S, plus the next coefficient is F into s to the power of, after 2 we have to decrement by considering alternate power of S, so s to the power of 0. So the auxiliary equation will be equal to ds to the power of 4 plus es square plus f. This is the first step. Next, we have to take the derivative of auxiliary equation with respect to s. So when we differentiate this auxiliary equation with respect to s, we get dA of s divided by ds is equal to 4d s to the power of 3 plus 2es plus 0. So the equation becomes dA of s divided by ds equals 4d s cube plus 2e into s. Now, The coefficients which we have obtained here, these two coefficients, whatever we have obtained, those two coefficients will be placed in place of those zeros which we have obtained. So in place of the zeros which we had obtained previously, we will be placing as 4D and 2E. And later, the last step is we'll complete the array in terms of these new coefficients which is obtained. So these are the steps which we follow in order to eliminate the special case 2 difficulty. Let us consider an example to understand this in a better way. Find the stability of the control system having the characteristic equation s to the power of 5 plus 3s to the power of 4 plus s cube plus 3s square plus s plus 3 equals 0. Now, the highest power of s which we have is s to the power of 5. 5 is the highest power of s. So s to the power of 5 will be taken. S to the power of 4, s3, s cube, s to the power of 2, s to the power of 1, s to the power of 0. The first two rows of the Routh array, the elements of the first two rows of Routh array will be directly extracted from the characteristic equation. The coefficient of s to the power of 5 is 1. It will be taken in the first row, first element. The coefficient of s to the power of 4 is 3. It will be taken as the first element in second row. The coefficient of s to the power of 3 is 1. It will be taken as the second element, value of the second element in first row. And the coefficient of s to the power of 2 is 3. It will be taken as the value of second element in second row, and it continues 1, 3. Now, next, to find the other elements or other values in our Routh array, we will be using our normal formula which we have seen in our previous lecture videos. To obtain this value, 3 into 1 minus 1 into 3 divided by 3. The value which we get will be equal to 0. Next, to obtain this value, 3 into 1 minus 1 into 3 divided by 3. Again, the value becomes equal to 0. Because there are no other terms over here, the next value will also be equal to 0. Now, if we observe in third row, that is s to the power of 3 row, all the elements which we have got in that row is equal to 0. So when all the elements in a row is equal to 0, we have to go for special case 2. So to eliminate this special case 2, we have to follow the steps which was discussed previously. Now, all the elements in s to the power of 3 row are 0. Hence, we have to write the auxiliary equation. So when we have to write the auxiliary equation, whatever in whichever row we have got all zeros, just above that whatever row we have, using the values of those rows, that particular row will be writing the auxiliary equation. So the auxiliary equation A of s will be equal to, beside 3, the power of s which we have is 4. So s to the power of 4 is the value which we have. So 3 into s to the power of 4 plus the next coefficient is 3. 3 into, we have to consider the alternate power of s. So after 4, we should not consider 3. We have to consider 2 plus the next coefficient is again 3. 3 into s to the power of, we have to take the alternate power of s. We should not consider 1. We have to consider as 0. S to the power of 0 is in how? 1. So this will be equal to 3s to the power of 4 plus 3s square plus 3. So this is the auxiliary equation which we obtain. The same equation is being written out here. 3s to the power of 4 plus 3s square plus 3 equals 0. Next, we have to differentiate the above equation with respect to s. So when we differentiate this auxiliary equation with respect to s, we get 12s cube plus 6s plus 0. Now, the coefficients, whatever we have got here, this 12 and 6 are the coefficients which we have got. These two coefficients will be placed in the rows of zeros, whatever we had obtained previously. Now, so in place of this 0 will be writing as 12. In place of this 0 will be writing as 6. It is as shown. So S cube row 12 and 6 is placed. Next, after this we will start filling the Routh array. So to fill the next values, this particular value of s to the power of 2, 12 multiplied by 3 minus 3 multiplied by 6 divided by 12. The value which we get will be equal to 1.5. Similarly, to get this value, 12 multiplied by 3 minus 3 multiplied by 0 divided by 12. So the value which we get will be equal to 3. Next, after this we don't have any other values, so if we don't have any other values, it will be taken as 0. So the next value, that is the third element in the fourth row, is equal to 0. Next, to get the value corresponding to s to the power of 1 row, 1.5 into 6 minus 12 into 3 divided by 1.5. The value which we get will be equal to minus 18. Next, 1.5 multiplied by 0 minus 12 multiplied by 0 divided by 1.5 will be equal to 0. Similarly, the next value will also be equal to 0. Next, to get the value corresponding to the last row, s to the power of 0 row, minus 18 into 3 minus 1.5 into 0 divided by minus 18. The value which we get is 3. Similarly, minus 18 multiplied by 0 minus 1.5 into 0 divided by minus 18 will give us 0. Similarly, the next element will also be equal to 0. The next value will also be equal to 0. Now, whenever we are predicting the stability, we always consider the first column of Routh array. If we observe with the first column of Routh array, if all the values, if in the first column of Routh array, if there is no sign change, then we call it a stable system. If there is at least one sign change in the first column of Routh array, then we call that the system is unstable. If we observe here, we have plus 1, plus 3, plus 12, plus 1.5, minus 18, plus 3. If we clearly observe, from plus 1.5 to minus 18, these two, we have one sign change. Minus 18 plus 3, we have one more sign change. So there are two sign changes here. So because there is sign change in the first column of Routh array, this system is said to be unstable system. I hope that you have understood this video lecture. Thank you.